Hi guys, it's Ms. Griffin. We're taking a look at Unit 5, Skill 2, Part A. There's actually 3 parts for Skill 2, Part A, B, C, so today we're going to just focus on one of them. Our essential question says, how can we determine a missing segment when triangles are inside of one another? And what makes the bases parallel? So we're taking a look at side splitter and justifying parallel lines here. And our first example says that we're given triangle ABC if D is on AB and E is on BC, with DE parallel. That's what this symbol means. So when we mark this, that means parallel. AD is 2, BD is 4, BE is 6, and we need to find BC. So whenever you're looking for something, choose to call that X. So BC is this entire piece called X. And so remember last time in the video that Miss Wesley just did with you in 5.1, she said you might need to redraw your triangles. Well, that's going to be something we constantly do here, is separate and redraw the triangles, as you see in your little side bank over there. So we've got triangle BDE up top with a side of 4 and 6, and then we have the big triangle ABC. So you separate it into the big one and into the small one, okay? And make sure that you label everything. We know that BC is the length of X, and then if I take 4 and 2 together, they make 6 to make the whole length of AB. So now we've got two triangles oriented the same way, looking the same as one another. One's just bigger, the other one's smaller. And because these lines are parallel, this is an important piece of information. When we have these lines that are parallel, we know that corresponding angles are congruent. If I were to extend these two lines and draw this transversal in, you know that angle A from the big triangle and angle D from the small triangle are congruent to one another. And same idea with angle E in relationship to angle C. And angle B is just in both of them, so that means they're congruent. So we've got all angles congruent, and you might be like, wait a second. AAA is not okay, except that it is a good thing when triangles are similar. Okay, so AAA is okay for similarity. Okay, so that's something you need to recognize. So now that we know that the triangles are similar, we can set them up in a proportion to solve for X. So remember to be consistent with your proportions. So if I start from the small triangle, I have to match it with its big triangle side. So I might go small triangle over big triangle here with 4 over 6, and then I have to go small over big again, 6 over X. So then we just cross multiply to solve. 4X equals 36. Then you're dividing to get X by itself. This is a nice simple one. So then X equals 9. Or in other words, BC equals 9, because remember that was what we were trying to solve for. Okay, so first step, separate and redraw the triangles, relabel them, and then set up a proportion. Go ahead and start example 2. Remember that as you read, you should be labeling, and then hit play when you're ready to see the next step. Okay, so this time they gave us a whole segment, AB, a partial segment, AD, and then the bases as 9, and then we're looking for X. So we're still going to separate and redraw this, because remember, we still know that the triangles have congruent angles because of the corresponding parts, the corresponding angles. Remember, again, that comes from here and here, or any other matching pair. So we've got this top triangle, BDE, and we've got the big triangle, ABC. And we know the base on the big is X. We know the side on the big is 6. We know the base on the small is 9, but we need this side here. And I don't want you to call that X again, because this is some math that you can very, very easily do. We've got 6 here, and part of it's taken up by 2. So 6 minus 2 will give you that remaining part of 4. Whenever you have a big piece and a small piece, or two smalls to make a big, you should do the math that's there in order to find that missing segment. Before you even separate and redraw the triangles would be the most beneficial, actually. So now we got to match up our parts. Similar to what we did last time, I always just start on the triangle that I have drawn on the left and put it over the triangle I have drawn on the right, which just happens to be small triangle over big triangle again. So for example, I have 4 over its matching part of 6. And then I'm going to think to myself, is it going to be x over 9 or 9 over x? And because, again, I'm doing small triangle on top, that means the 9 from the small triangle has to go over the x from the big triangle. So 9 over x. Go ahead and pause your video to solve that. You will get a decimal, so don't be scared by it. So I got 13.5, but if you're trying to figure out how to get a decimal in your fancy TI Nspire calculator, what you're going to do is type in your 54, you're going to type divided by, and then 4, but then I need you to put a big period after the 4, because then if you have a decimal in the problem, you'll get a decimal in your answer. Okay, so keep that in mind. 54 divided by 4, put a period or a decimal, and then you'll get a decimal answer when you hit enter. You have to put the decimal in before you hit enter, otherwise you can't do it. Okay? Flip to the next page so we can see a couple more examples. All right, so example 3 doesn't give us any numbers. It just says, which of the following statements is false if DE is parallel to AC? So I know that these two are parallel, so I'm definitely immediately going to separate and redraw my two triangles. And we've got DBE and the big triangle ABC. So when we're looking at these statements, we want to see, are they following a consistent pattern? So that could be like small triangle over big triangle. It could be left side over base. It could be right side over left side. It could be anything, really, as long as they are using the appropriate matching parts. And we want to make sure that they're consistent with both sides of the proportion. It also might help to stack your letters here, so I'm going to read this triangle as DBE, and then its matching parts would be A, B, C. Those could come in handy here too. All right, so we look at this first one, and it says DB, so that's small triangle, over DE. Okay, so that's still small triangle, but it's the small left over the small base. Okay, or the bottom, if you prefer bottom. So that means the right side should be the same thing, but from the big triangle. AB, left side, so that's big left, over AC, big right, or big base, sorry. So we went left over base, left over base. That is absolutely perfect. So that means it's a true statement, because we were consistent in our proportion. Okay, let's try the next one. So we've got BE, that's from the small triangle, over EC. Ooh, wait a second, that's not in my redrawn picture, so we have to take a look at the original picture. They give me BE over EC, so it looks like a top section over a bottom section. And then they give me BD, another top section, over DA, another bottom section. So we want right top over right bottom equals left top over left bottom. So that one's okay too. If you want to sketch that out real quick, we had left top over left bottom. And that was equal to the right top over right bottom. Just so when you look back at this, you can see like, oh yeah, these were consistent, right? Because you're all going to look back at your notes. The next one says BD. So I'm going to, again, come back to my separated and redrawn triangles. BD and DE. So it looks like I went left small over bottom from the small triangle. And they're saying it should be equal to DA. Okay, that's way back over here. Over AC. So if I'm using AC, the base from the big, so this is the big bottom, then I should be using BA on the top because I went side over base equals side over base, but they didn't do this side. They used DA, this little portion, instead. So choice 3 is a false statement, but let's just check choice 4 to be sure. So choice 4, we've got BD over BA. So here's BD over BA. So that looks like small triangle over big triangle equal to BE, small triangle, over BC, big triangle. So they were matching parts, they did match up with the triangles, therefore that's a true statement, which is not the choice we want to make. These take some time to understand and to work through, so just make sure that you check your proportions, you redraw your triangles, you highlight things just like you saw me doing, and then if you have questions, of course, please ask. And last but not least, example 4, this came right from a Regents exam. It says, in triangle CED shown below, points A and B are located on CE and ED respectively. Line segment AB is drawn such that, and then they give us a bunch of segment numbers, and those are already marked up for us. It says, explain why AB is parallel to CD. So first things first, when the pictures are inside of one another, you have to separate and redraw them. So we have A, E, B, and we've got 3.75, 4.5, and then we have the big triangle, C, E, D. We're going to have to do a little bit of math to find out these lengths. So the right side is 10.5, and the left side is 8.75. And all I did was add. Right, to make a total, you just add. So now we're going to set up a proportion to see if the lines are in fact parallel, because if the proportion works out, then our lines are parallel. So I'm going to match up some parts. We've got small triangle over big triangle, or you could go big over small, it doesn't matter. So for me, I've got 3.75 over 8.75. And then the other one is 4.5 over 10.3. You might be like, wait, Ms. Griffin, there's no x in here, we're not solving. But in fact you are, because you're going to say, are these equal to each other? Because remember, if they're equal, meaning the sides are in proportion, then you know that your triangles must have parallel bases. So I'm going to type this left side into the calculator, and it's going to give me a reduced value. Sometimes it reduces a fraction, sometimes it reduces as a decimal. If there's decimals in the problem we type in, though, it will give us a decimal answer. So I'm typing it into my calculator, I'm getting 0.42857. Then I'm going to type the right side in and hope that I get the same thing, because they said explain why they're parallel, so they should be equal. 0.42857 again. So now I say equals, I check it off, and I'm like, yeah, this is the coolest thing in the world, right? But then I have to actually make a statement, because it says explain, so that means words. So we're going to say that AB is parallel to CD because corresponding, remember that just means matching, corresponding sides are in proportion. That's a phrase that you guys gotta get memorized. Just like CPCTC for proving congruent, you have to memorize the phrase that corresponding sides are in proportion. Therefore, the triangles are similar, therefore the lines are parallel, therefore, etc. Corresponding sides are in proportion. Okay, if you have any questions, feel free to ask us. Otherwise, get started on your practice before taking a CFU. Adios.